The purpose of this report is to summarize the data, modeling, and sensitivity analysis that was collected and conducted by Team Number 10 on the project operations currently occurring at the province at Tuscaloosa. The province in Tuscaloosa is located in Tuscaloosa, Alabama. It is located close to the University of Alabama School of Law and the DCH Regional Medical Center.
The province of Tuscaloosa is a high-density residential project that is going to consist of 4 apartment buildings. The general contractor for this project is Price Construction. The apartments are mainly intended to provide housing to students because of the site's close proximity to the UA campus. The construction of these buildings will involve earthwork, utilities, and actual building erection. Right now, the buildings are in the preliminary phase of laying down the roads and the foundation. During Team 10's initial visit to the job site, there was one big issue that Price Construction was facing. This issue was that some of the soil was not passing compaction tests. Price Construction decided they needed to excavate and haul the soil off-site so that in the future they could bring in higher quality soil so that it could be compacted and pass the compaction tests. Team 10 decided to focus on this process involving excavation and hauling of the low quality soil to model and optimize. Team 10 decided to model the process using EasyStrobe software. There were 7 steps to the process. The first step was the actual loading of the dump trucks. This involved an excavator and a dump truck. Second step involved washing the mud and dirt off of the tires and chassis of the dump truck before it left the job site. Third step involved traveling through a parking lot to the roads. The fourth step involved actual highway travel on the roads from the job site to the dump site, located off Old Birmingham Highway in Cottondale. The fifth step was dumping the soil. The sixth step was returning on the highways to the job site, and the seventh step was returning on the job site from the roads to the actual spot of the excavation. As you can see from our model, there are 5 different queues where the trucks must wait during the modeling process. The first queue is while the trucks wait for other trucks to be loaded. The trucks must wait in line behind the excavation site. The second queue comes up after the trucks have been loaded and they wait to have their tires washed off before they can leave the job site. If other vehicles are having their tires washed off, then the trucks must wait their turn because there is only one tire washer. The third queue comes when the trucks are trying to leave the actual job site. After their tires are washed, the trucks must navigate a one-way road to leave the job site. If there are trucks coming in or other vehicles, the truck must wait until the road is clear. The fourth queue is where the trucks are dumping the soil at. If there is another truck already dumping its soil in the borrow pit, then the trucks must wait for their turn. The fifth and final queue is when the trucks return to the job site and must ensure that the one-way road is open to return to the spot of excavation. Then they encounter the other queue that involves waiting to be loaded.
This table is a representation of the 2 different excavator bucket sizes and the optimization of the dump trucks. The table shows 3 different methods of project optimization. It compares production in cubic yards per day, the overall duration of the project, the cost of each individual cubic yard, and the total cost of the project for each of the listed scenarios. By inputting the information from the previous table, there were 2 optimal scenarios. The first scenario was cost-driven, while the second scenario was time-driven. Team 10 found that by adding 5 trucks to the original baseline of 1 truck, 6 total trucks provided the lowest cost per cubic yard and the lowest overall project cost. The lowest cost per cubic yard that could be obtained was $3.62. In the second scenario, Team 10 calculated the limiting amount of cubic yards per day that can be hauled when 7 total trucks are used. The excavator becomes the controlling factor of the model, and the maximum of 1381 cubic yards per day can be hauled. This will shorten the project time by 0.6 days, but will also cost Price Construction around $2,000 more on the overall project. Team 10 found that the Price Construction Company would have the lowest cost operations if they used 6 dump trucks, and would have the largest amount of material excavated and hauled if they used 7 dump trucks. Price Construction should use a total of 6 dump trucks if their client is cost-driven. However, they should use a total of 7 dump trucks if their client is schedule-driven.